the Chapter 4 test, which will be Wednesday, last test for the semester. Okay. That being said, the end of the semester survey about whether you want to do a test retake or take a doubled high test score is available under the announcements on My Notre Dame. If you know what you want to do already, go ahead and fill that out. If you're like, well, I want to wait to see what I get on the Chapter 4 test, I understand. You can wait and do that, but if you know what you're going to do, go ahead and fill that thing out. All the rest of the drops and stuff they're already being current, like I set it up to just start doing the drops right away. So we're going to do content from Chapter 5, but there'll be no quiz or test. It'll be the last set of topics we're going to do by Maya. It was probably Allie texting her to come let her in, huh? Sound good to you guys? Okay. I do. So if I look at the announcements, the IB test date are Thursday, May 15th and Friday, May 16th. It's the afternoon session is on the Thursday and it's the morning session on the Friday. Yes.
Yes. Morning of month.
The morning of. This is a Thursday and a Friday. All right, everybody good on the test dates? I don't have the times for these things yet. I suspect when you go to your mandatory IB meeting, yeah, tomorrow, during CT, report directly to the library. I'm sure they'll give you a time schedule at that point. All right, let's get it done for this. Oops, I guess I didn't have a picture of this. We'll just. So it says a grain cylinder has the shape of a grain container has the shape of a cylinder with a radius 3.5 and a height of 7. And then it says the roof of the container is a hemisphere, as shown in figure yada, yada, yada. I guess I forgot to drop that in. Let me grab that figure. I think we probably all know what this is pictured, though. Anybody having a problem picturing a cylinder with a hemisphere like glued to the top of it? Oh, it looks like a silo like you'd see on a farm, right? You guys had farm toys when you were a little kid? Had a silo on it, probably. Like boosh. Like there you go. All right. It says find the volume of the entire grain container. So the total volume should be the volume of the cylinder plus the volume of the hemisphere, right? Everybody's good with that idea? The volume for a cylinder is pi r squared h. And the volume for a hemisphere is going to be 1/2 the volume for a sphere. So then we just fill in. And we're done, right? No big deal. Okay, it says find the surface area for the container. So first thing to think about is which are actually surfaces, right? So the surfaces that are going to be exposed to the air is just going to be the sides and the top of this thing, right? Everybody agree with that, looking at the picture? So the sides are relating to the cylinder. So if I go back and I look at my surface area for a cylinder, 2 pi r squared plus 2 pi r h. So which parts are we going to dump? We don't need the bottom because that's on the ground. And we don't need the top because that's being covered by the hemisphere. So we're just dropping that part off, right? So just going to be 2 pi r h. So you guys all feel okay there with how I adapted that? And then the top is the hemisphere. So that's this guy. And then we just fill in. The hardest part is being able to look at the picture and know how to like adapt your formula to fit what's being asked, right? Particularly with the surface areas, I might not take the entire formula, depending on what's an actual surface and what's not.
So when you found the volume of the hemisphere, why didn't you just use the 2/3
because I didn't realize that they had a separate hemisphere formula. I think it's insane that they do that,
Okay.
but okay.
So what are you the same thing?
Yeah,
Okay.
1/2 times 4/3 is 2/3.
Yeah. Just pi r cubed.
Yep, that's what I wrote.
Okay.
All right. Next one, a chocolate bar in the shape of a right triangular prism, as shown in figure 4.35. Calculate the volume of the chocolate bar. So our volume is, it said it was a right triangular prism. So we need this guy. That's the area of the base times the height, or the length. I guess they had it L. I don't know why they want to. Okay, that's fine, whatever. So the base is a right triangle. So that's going to be 1/2 base times height, right? We have the base. That's 2. What are we missing, though? The height. What are we given instead? We're given this angle measure, right? So the way I would think about this, I'd go, oh, look, that's a 30, 60, 90 triangle. So I know this side is like x, x root 3, and then 2x. So I know that that height is 2 root 3. Now you could have also done like use tangent or whatever and said tangent 60 is equal to x over 2 and solved it that way. That would be fine. So when we plug this all in, we have 1/2 times 2 times 2 root 3 times 5. Everybody feel okay there? Okay. Next, it asks for the surface area. So when I think about the surface area, what do I see? I see 2 triangles, right? Those are the bases. You guys agree? And then I see 3 rectangles, and those 3 rectangles are all different sizes, right? You guys agree with that? So the area of the triangle, we already did that. So rectangle 1, I'm going to say is this one down here. So that's 2 times 5. And we'll say rectangle 2 is this one. That was 4 times 5. And then we'll say rectangle 3 is this one back here. Oh my goodness, that's a thick pen. So that is the 2 root 3 times 5. Apparently that's too thin. I didn't use a formula, I just looked at the picture. I think the table at the top is what you would get. All right, let's see. The Cheops, you think that's how we pronounce that? Not sure. Pyramid in Giza, Egypt, shown in figure 4.36, is a right squared pyramid with a square base. With a base length and width of 230 meters and a height of 147 meters. 3 of the base vertices are labeled B, C, and D, while the apex is labeled A. The projection of the apex on the base is labeled O. Find the volume of the Cheops pyramid. So I know the volume is 1/3 area of the base times the height. I just pulled that from the formula. The area of the base is a square, so that's just going to be 230 times 230. And the height of that pyramid is that segment O or AO, which we're told is 147. So that's that. Part B says to find the length of the diagonal DB. So to do that, I'm going to use this right triangle. Everybody's okay there? Now I recognize this is a 45, 45, 90 triangle. So x is going to be 230 times the square root of 2. You could have also used the Pythagorean theorem there. You'd get the same result. Then it says find the length of AB. So to do that, I'm going to use this triangle here, AOB. Now we know that AO is 147. We're told that in the problem. And if I look at OB, that should be half of AB, right? Or I'm sorry, half of BD. Do you remember why that is? From geometry, we should remember that the diagonals of a square are perpendicular bisectors of one another. So if O is like the projection for the height of that pyramid, you know, O should happen right in the intersection of those two diagonals. Is that okay with you guys? And it looks like it should be that way, right? It says drawn not to scale. It's probably pretty to scale. So that's going to be 115 square root 2. So we can Pythagorean theorem that. Is everybody okay with what we did there? Next, it asks for the size of the angle BAC and then the angle OBA. I guess we probably need an answer to that. Ugh. It's not going to be. Apparently, the calculator doesn't want to open for me. We'll do it by hand then. So this is, we'll call that 219.2. And we're looking for this angle here. What I'm going to do is I'm going to drop a perpendicular bisector. Because this is an isosceles triangle, I know that those two angles are bisected by that, and that height then is going to bisect the opposite side. So I can say that sine of angle, I guess I'm going to give this a name, we'll call it point X. AXB is equal to 115 over 219.2. So I can say then angle BAC is going to equal 2 times angle AXB, which is going to equal 2 times sine inverse 115 over 219.2. So that's going to be about 63.3 degrees. And then the other angle it wanted was OBA. So that's easy. Angle OBA is just going to be the cosine inverse of tan inverse of the opposite over adjacent. So that's about 42 degrees. And then part E says then to find the area of the triangle ABC, and then the lateral area of the Cheops pyramid. And they tell us the lateral area is the total area of the triangular faces. Well, that should be easy because we can do 1/2 AB sine, well, we should probably call them BC sine A. And then my lateral surface area, well, there's just 4 of those triangles. So it should be 4 times that answer. And what units? These were meters or something, right? What do you think? Hopefully that seems okay. Test description. This one's on the long side, be warned. Although the things in here are pretty quick to do. But just FYI. It was a lot of pages when I printed it. Yeah, part of it is that there's pictures and stuff. Because you have like the 3D pictures and the drawings and like got to plot points and stuff. So there's extra, but you know, there's a lot of pages. Should be able to find the distance between 2 points. Find the midpoint of a line segment. Find the equation of the perpendicular bisector of a segment. Plot lines on an XY axis. Find the intersection of two lines algebraically. Woof, did we have a hard time with that on the quiz. Solve for sides and angles in a right triangle. Solve right triangle story problems, possibly using angles of elevation and depression. Solve for sides and angles in non-right triangles, and then surface area and volumes. Everybody happy? Yeah. I'm talking about using the law of sines and cosines.
Oh.
We got some papers to pass back. And then we'll
I know.
Yeah.
Oh, yeah. Show me.
Race. Show me. Ollie.
Don't test.
Oh, wait.
Yeah, this one. I did this one.
And then you girls that were gone. But that's just letting you know why you didn't get a paper back.
Yeah.
Feel free to look on at somebody else's to see like what did I ask about or whatever. You know. Yes.
My test. You're still getting my test, right?
Yeah, I have it here. I just didn't get to it.
It's all good.
Yeah, you gave it to me like Friday, yesterday or something, right?
Yeah.
Yeah. It's on my to-do list.
It's all good.
Okay. Well, I got it.
Yeah.
All right, here, folks. So you've seen the test description here. Is there things from this description you want to do practice of right now?
Could we do, yeah, let's do the perpendicular bisect.
Okay. Okay. So here's a line segment. If we want to write the perpendicular bisector, that's a line, right?
Yeah.
To write the equation for the line, we need slope and we need a point, right? So the point is going to be, I guess let's give this line a name here. Call it AB. The slope is going to be the negative reciprocal of the slope for AB. And the point is going to be the midpoint for AB. Everybody's good with that plan? All right. Let's start calculating. So the slope for AB, I just did y2 minus y1 over x2 minus x1. I get negative 5/6. So the slope for my bisector is going to be positive 6/5. The midpoint is going to be the average of the x's and y's. So it's going to be 2 negative 1/2. So if I take those and put it together, there's my equation for the line. Depending on the directions, you might need to rearrange that to put in slope-intercept or standard form or whatever, but
But it wants to change it.
the directions would tell you what to do, yeah. So the most common mistake I saw in quizzes was people not using the midpoint.
Could you do, I guess, find the intersection of two lines?
Yeah. So if my lines are written in slope-intercept form, I'm just going to use substitution. Since they're both equal to y, I can set both of them equal to each other. So I can just add the 1/2 over and then subtract the 4 and then divide both sides by 2/5. I get x equals negative 2. I meant negative 4. And then I can just plug back in to either equation, it doesn't matter. So my solution should be negative 4, negative 4.
For solving sides, like triangles,
That's SOHCAHTOA. Yep, if they're right triangles.
could we do maybe one story down on the triangles?
Mm-hmm. All right. It says a projector is mounted on a vertical wall. And call that vertical wall AB. Says a beam of light from the projector makes a 20-degree angle at A. So there's like my beam of light. So there's my 20-degree angle. So far, so good. I'm going to call these 2 points C and D then. The light makes a circle with a diameter of 9 meters on the ground. The distance from the projector to the closest point on the circle C is 12 meters. The distance between B and C is 10 meters. Then it says find angle CDA. So I would be using the law of sines here because it's not a right triangle. So I would say sine of 20 over 9 is equal to sine of angle D over 12. So if I cross multiply, I get 9 times sine angle D equals 12 times sine of 20 degrees. Divide both sides by 9. And then we'll do sine inverse to both sides. Yes,
Will we be given like the formulas for law of sine for sine?
I think so.
Okay.
So I get 27.13 degrees.
Well, is it like solve for right triangles or not? Or just let's do it like regular.
Right, if it was a right triangle, you just use SOHCAHTOA.
Do the last two.
Oh, well, this needs to, there's still part B here. So it says a 3.6 meter high wall has to be erected between B and C. Find the furthest point from B at which this wall can be placed without blocking the light from reaching the circular area. Give your answer to the nearest meter. Just do it this way. So here's my plan. So I drew my little wall in here, right? So what I need to do is I need to be able to solve this and actually I think I'm going to rewrite this. I think I'm going to put the 10 minus x over here and the x over here. It'll just make the algebra a little simpler. So I'm going to solve this for x, but I need one more piece of information in this right triangle to do anything, right? The piece of information that I'm going to get is going to be this angle here. In order to get that angle, I'm going to find this angle measure here, because I already know that the other two angles in that obtuse triangle so that's going to give me 132.87. So this piece is going to be 180 minus that 132.87. So now I can say that tangent of 47.13 equals opposite over adjacent. Cross multiply and then divide. So that x is about 3.3. So my answer should be 10 minus 3.3. So I'd say like 6.7 meters. I guess the question asks us to round to the nearest meter. Should I be rounding up or down? Think about the picture though. What do we want that wall to do? Can't block the beam, right? So if I round up and push it further to the right, it's going to block the beam. I need to make sure I'm rounding down to the nearest meter, even though it's 6.7. So was tricky with the rounding there. You had to think about what you really need to accomplish. Does that feel okay?
Will those always be like with the angles are side by side of each other? They always be like that.
Yeah, that's called a linear pair. So two angles on a straight line make up 180 degrees. So if you see two angles next to each other on a straight line, you can always do that. What do you guys think? It's okay? All right. I'm good if you're good. You guys good? The next bullet point, what does it say? Well, we just did one in part A, right? So it was like a story problem. We did that inside of the story problem. Is that okay? No?
Yeah.
It's okay? I mean, I do it, Grace, but we did it. You know what I mean? No? Yeah? No? Yes? Maybe? Why don't you look over some stuff on your own if you're stuck on something or you're not sure? Holler at me. Look at the review or look at the homeworks from those sections. See if there's something that looks hard that you're like, I'm not sure what to do with this right away. Or I did this and checked it and it's not right. Holler at me. We got 40 whatever minutes left in here. You guys okay with that plan? Everybody's very motivated today. 8 more class days until spring break, though. And really, might as well call it 7 because you've already woken up for today.